Potential energy. An object can store energy as a result of its position. For example, the heavy ball of a demolition machine is storing energy when it is held at an elevated position. This stored energy of position is referred to as potential energy. Similarly, a drawn bow is able to store energy as the result of its position. When assuming its usual position, when not drawn, there is no energy stored in the bow. Yet, when its position is altered from its usual equilibrium position, the bow is able to store energy by virtue of its position. This stored energy of position is referred to as potential energy. Potential energy is the stored energy of position possessed by an object. Gravitational potential energy. Gravitational potential energy is the energy stored in an object as the result of its vertical position or height. The energy is stored as the result of the gravitational attraction of the Earth for the object. The gravitational potential energy of the massive ball of a demolition machine is dependent on two variables: the mass of the ball and the height to which it is raised. There is a direct relationship between gravitational potential energy and the mass of an object. More massive objects have greater gravitational potential energy. There is also a direct relationship between gravitational potential energy and the height of an object. The higher that an object is elevated to, the greater the gravitational potential energy. These relationships are expressed by the following equation. Potential energy equals mass times gravity times height. In the equation, m represents the mass of the object, h represents the height of the object, and g represents the gravitational field strength, 9.8 meters per second squared on Earth, referred to as the acceleration of gravity. To determine the potential energy of an object, a zero height position must first be arbitrarily assigned. Typically, the ground is considered to be a position of height 0, but this is merely an arbitrarily assigned position that most people agree upon. Since many of our labs are done on tabletops, it is often customary to assign the tabletop to be zero height position. Again, this is merely arbitrary. If the tabletop is the zero position, then the potential energy of the object is based upon its height relative to the tabletop. For example, a pendulum bob swinging to and from above the tabletop has a potential energy that can be measured based on its height above the tabletop. By measuring the mass of the bob and the height of the bob above the tabletop, the potential energy of the bob can be determined. Since the potential energy of an object is directly proportional to its height above the zero position, a doubling of height will result in a doubling of the potential energy. A tripling of the height will result in a tripling of the potential energy.